So we are really focusing on confidence intervals for just me, right? We have confidence intervals for other things too, for standard deviation and things, but we just doing it for mean and proportion. Right, so head up confidence intervals. And I just want you to do one, and then I want to explain how they got that, right? Let's write it first on. Hold on, eh? So write down confidence intervals, normal population, node variance, and write down the formula. I want to show you how they got it, right? Oh, oh. All right, so you need your tables, right? So you have it. You can always go back and get it. So let's see if we can prove that same formula there. Oh wait, I have to rub it off. Just now online. I'm doing some writing there, and I will show you back the screen that's now. So x bar follows minus 1 point, well, it's plus and minus 1.96 sigma on root 10. Right? This one is from known. So sigma squared known and large sample size. No matter large or small. And you have sample mean, right? Let's get this a little charge. Right, so where did this come from? So you end up in exams and you can't remember the formula. Let's see if we can work it out. Right? So you hear where we want to be. We want to create a 95% confidence interval. CI means confidence interval. Right? So what does that mean? It means something like this. Right? It means that for this distribution, actually, let's describe a distribution. X comes from a normal, right? With mean, mu, variance, sigma squared. But what distribution we actually using to develop this? X or X bar? X bar, right? Because it's a confidence interval for mu. So we need X bar. X bar follows a normal, mean, mu, and sigma squared on N. That's okay? Nice. So, right. So here we have to be 95% sure, which is here. Here is 95%, right? So here is 95%. So we have 5% to divide up here. So here will be 2.5%. Here will be 2.5%. Right? I am interested in getting these values here. Right? Any idea how to get this value? This probability here is 0.025. Right? So what would be the value here that we didn't know for? 0.1 minus this, right? So that will be 0.975. Yeah. Do my favor now. Go to your tables and read off what gives a probability of 0.975. Go to the same table I gave you, right? Hmm? 1.96. So this value here is 1.96. This value is minus 1.96. That's okay? So all that will really change in these questions, it's gonna be the same formula. What we're gonna change is that 1.96 value. So what I'm trying to show you is how to get that value.
Apply you on the syllabus, it's not 2023, it's the same unit to pilot, so that's why it's
Okay.
Right, so that is all.
Right. So now here's what we want. We want the probability that Z lies between two values that gives a probability of 0.95. So we know that if Z lies between minus 1.96 and positive 1.96, then that probability will be 0.95. Are you okay with that? You're okay how I got this value here, right? If I give you 90%, you have to be able to develop the formula as well. That's okay? All I'm going to change is this value in front here. Right? That's like call it a critical value. Okay? Now, how do I turn this into that formula? Well, since Z. How do we get Z? Well, you might remember that to get Z, it will be X minus mu all over sigma on root 10. Remember that? The value underneath here is the square root of this. That's okay? But remember, we're trying to estimate mu, right? So this will be X bar. So if I drop that in here, so the interval looks something like this. The interval looks something like this. Minus 1.96 is less than X bar minus mu all over sigma on root 10 is less than 1.96. Okay with that? Now, let's focus on one side. Let's just do this side, then we do this side. So, minus 1.96 is less than X bar minus mu all over sigma on root 10. That's okay? Yeah. So if I were to move across everything, right? Let's move it on this side. I'll get minus 1.96 sigma all over root 10. So you might see it coming together a little bit. It's less than X bar minus mu. That's okay? So let's carry across X bar. Well, actually, let's switch everything around. Let's put this on this side, so I'll get positive mu. All right. And that's locking up the gate, right? Mu minus X bar is less than 1.96 sigma. That's sigma, yeah? All over root 10. Right? So now we have mu is less than X bar plus 1.96 sigma all over root 10. Okay, that? So what it's saying now is mu has to be less than this. This is our upper boundary. Right? And you saw it in your formula, right? And now if I rearrange the left-hand side, I will get X bar minus mu all over sigma on root 10 is less than 1.96. If I rearrange this, I'll get mu is greater than X bar minus 1.96 all by sigma on root 10. So I have my lower boundary and my upper boundary. So therefore, my confidence interval for mu has to lie between this X bar minus 1.96 sigma on root 10 and X bar plus 1.96 sigma on root 10. That's okay? So this is how you prove it, right? But basically what you have to understand is this is what the formula will always look like. Formula will always look like this. What you have to figure out is number one, did the question give me sigma? Did the question give me the variance, or do I have to estimate it? If I have to estimate it, then put the hat on top. If I don't have to estimate it, then this formula looks like this. And then what's the confidence interval? If it's 95%, then it's this value here. If it's 90, you have to be able to work it out. Right? So all you're interested in is reading this value of it over 7. All right, copy it up. Right, the problem with this, right, is number one, you don't always get sigma, so you gotta work it out. And number two, the distribution could be normal, it could be non-normal, and it could be a new distribution called T. Right? So getting this value is a little tricky. So we gotta look at all the different cases, right? Any questions online? In case you're now joining or you're now trying to pay attention, this is the formula where to pay attention to. How to find confidence interval. We need sigma, we need n, we need x bar. Right? When you copy it down, remember this is a confidence interval for 95%. I want you to try to find it for 90% and 99. Do not do this long process. All I want you to do is to tell me the value for here and here when it's 90%. So it's x bar plus and minus some critical value, sigma under root 10. See if we can figure out how to get that value. So yeah, totally normal down. That's not answer. That's it. Take what we've done. And not like. Thank you. Much again? If it's 90%, are you right, pencil? So remember, if it's 90%, I want to see what critical value you get here and here. 90 and 99. That's 99, right? What you got? Which one is it? Which one is it? Yeah, next. Next. Where you get for 90%. Still getting true? Well, guide me now, tell me what are we supposed to get? What would be the values here and here? If here is 0.9, how much is here and here? Right, okay. So the value that we're reading up here is what? 0 point? No. Here is, so the whole thing is 10%, right? So here will be 5%, 5%. So the value here will be 0.05. But what's the remember, we are going to read off for all of this. So all that corresponds to 0 point what? See how we read off for 0 point? You see how we read off for 0.975 there? What's the value we're going to read off for? 1 minus this. Yeah. 0.95. So tell me what that is.
So 1.6.
Yeah, that's cool. Yeah, no, without. Now, I'm going to put it up. What do you guys tell me? What do you guys think? How much you got?
1.6.
1.645. Anybody online got that? Get up 1.645. Do the next one from 99%. Today before you go there. Right? After you do plenty of questions, these values stick in your head. To 199% quickly. And when you see how we get this? right? You minus one minus this, and then you read out from it straight from the tables what is 0.95. Yeah. Anybody online can give me this value here? What's the value when it's a 99% confidence interval? Right? You don't have to overthink it. Remember, it's just all you have to do is 1 minus half of the remaining. So the remaining is 1%, 1 minus half of that. That's the value you're reading from a table. So that's what point 995. Yeah, 0.995. How much is that? What? 2.574. Might have more than one option. 416. All right. Good. Let's try question now. Let's try this here. It's an old Cambridge question. Let's try this here. Real basic. Online, right? Let me see what actually here online, right? Okay, shall be there. Right. Send your answer, right, Keshav? I'm glad you did. All done? Finish? Have a look. Right, so let's identify, remember it has different types, huh? All will follow the same thing, right? So you have to pay attention to what's the knowns, what's the unknowns, right? And what distribution they use it. So let's start here. They told us it's normal. And they gave us standard deviation. They gave us a random sample of 5 capsules. Right, a random sample of 5 capsules was analyzed. And they gave us a mean. Mean was found to be 5.12, right? What that is? What is that 5.12? You what? Which symbol there? Mu, no. Mu is the population mean. That's your what? Right. That's your X bar. Right? So you have N here. So N appears to be 5. Sigma appears to be 0.042. Your X bar appears to be 5.12, and they give you a confidence interval of 95%. Right? Show the endpoints. All right. Copy it down. Which will look for the endpoints. Where you get for the lower boundary. Right, and the upper. 5.1. Online better answer now. Message what you all got to the boundaries. I'm thinking about a small break around it. Okay? Don't get excited. Anybody online saying anything?
So ask questions.
Sebastian sent anything already? Sebastian, yeah, right? And who's that? Devana. Devana, get it right too. This is Devana. All right, let's check it out. 95%, right? So it's good when it's intervals that I give you. Sometimes you might see 94 and 92 one thing, eh? Right? So you is important that you know how to work it out, right? So I'm gonna work this one out here for you. And then we take a look at the different conditions, right? As I said, what you have to remember is this general form. X bar plus and minus the critical value, standard deviation and root n. All right. I just want to write these. N is 5. Sigma is known. Sigma is 0.042. X bar is 5.12. That's it. Right. That is it. So we don't have to go and do that long proof again, right? I just like to write this because it's the distribution we're using. X bar follows a normal, right? With mean mu and standard deviation sigma squared on it, right? We don't have mu, right? So the confidence interval, sorry, 95% confidence interval for mu is given by that formula there, X bar plus and minus 1.96. 1.96 by sigma on root 10. Right? And you work your values out. So that will be 5.12 plus and minus 1.96 by sigma, which is 0.042 all over the square root of 5. And you work this out. Oh, by the way, if you do it wrong, then you would recognize that 5.12 cannot be found in the middle of your value. It should be found in between. Right? 5.12 should be found in between. Okay? So when you work it out, you got your boundaries to be 5.08 and then 5.16. So 5.12 is found in the middle there. Right? Right? Because remember, your X bar should be found somewhere in between there, right? But just in case you do something wrong, then you might recognize that now it's not falling there, so something wrong, well, check. All right? So those are your boundaries. Quick question. Suppose I wanted, this is the question, right? Suppose I wanted to get these boundaries closer to 6.12. What do I do? What do I affect here? I want to get X, I want to get my boundaries closer to the X bar. I want to be a little more accurate in many ways. There are two things you can do. Obviously, do what here, right? But there's something else I want to see that you can do. What else you can do? If I make n bigger, what will happen? If I make n bigger, this whole value here becomes smaller, right? And then this whole thing becomes smaller. So it means that I will add less and subtract less from this, right? So that's what I mean by increasing its sample size. All right? Are you clear now? All right, nice. Online picture. So if you go back here, I want to show you the other conditions. Right? So as I said, other things that can change is number one, we don't know X bar. We don't know sigma squared. We have to estimate it. That's number one. That's the first condition. Next condition is that we don't know if it's a normal. Why it is good? N is large and it's not normal. Why is good? N is big, like N is 100. But the distribution or the values didn't come from a normal distribution. What here's do? Here, use something. What is use? Again, let's see. Huh? 3 letters. Well, abbreviated by 3 letters. You use central limit theorem. So you see by central limit theorem, since n is large, it will follow a normal. Okay? And nice job, Stefan. And lastly, sometimes it comes from a normal, but we don't know sigma. And n is small. Right? So like in this case, if we didn't know sigma, sigma is unknown, right? Then we have to use a new distribution called T distribution. Right? So we'll do that one last, right? Because I want to show you how to read that T. Very similar. So these are the other conditions. So I gave you the first condition, these are the other. These are the other 3 conditions. Okay, see that? I'm going to zoom to the second and then I'll move it, right? That's the second condition. When it's a non-normal, we can use it. Just squeezing from a bi-central limit theorem, right? Squeezing for me. Right? Everything stays the same. But you must need that bi-central limit theorem. We're using this in the distribution. Next condition. When it is right, non-normal with known variance, you would recognize a little hat, right? There's a little hat on top there because we had to estimate it. Right? So pay attention to the hat, right? You could probably highlight it in your notes too. Oh, sorry. You'll recognize there's a little hat here because it's unknown variance, right? Again, nothing changed except for the fact that you have to estimate, right? Last one. Last condition. Last condition is a normal unknown variance sample size small. Right, so you'll notice two things in this one. You're using a t distribution and you're estimating x bar. Are you okay with that? Right, before we jump to the next one, right, I have a question. Right, before we jump to that, to the next question. Suppose, and that question could come in different ways, right? Suppose I give you the boundaries. I give you the boundaries, but I don't give you n. Can you work backwards and find n? Right? So you're gonna jump from here to right here. And all you have to do now is to say, well, 5.12 plus this is equal to this. And then solve it. Right? But just suppose, and this came in my earlier years, suppose they didn't give you a sigma and root n. What do we do? Suppose you have two things you don't know. What do we do? Two unknowns, right? So you use one equation with the plus, one equation with the plus, one equation with the minus. Two equations simultaneously. That's okay? Alright, so that's different ways they could make you do it like this, or they could give you the boundaries and ask you backwards. Alright? Alright. Let's try this one, then I will give you a small break. We now start. Very good. Oh, yeah, let's try it today. Any question? Let's try this one. This is an example from the text. Take a read of this one. After this one, you will get a 1 minute break. The fuel consumption of a new model car is being tested. In one trial, 50 cars chosen at random were driven on, by the way, these are actual things that I do in real life. Huh? You know, like when mechanics like to say this good better than that, sometimes there's a sample like 10, 15 cars and they conflicts. Right? The fuel consumption of a new model car is being tested. In one trial, 50 cars stood up at random, right? Chosen at random were driven under identical conditions and distances, covering 1 liter of covered on 1 liter of petrol were recorded. The results gave the following. Right? You have sum of x squared. Calculate a 95% confidence interval for the mean for the cars. Right? What's the first thing we need to know? Number one, is it normal? Not normal. But sample size large, right? So it means that by central limit theorem, we could use a normal distribution. Right? It's 95%, so we know the critical value. That's how much? 1.96. What about n? N is how much? 50. Well, we do have the variance. We do have the standard deviation as well. So you have to use the formula and find standard. All right, go ahead. Work out this. And I'll give you a 2-minute break and then we will go to T distribution. I can show you how to read the first before we are. right? But you all got the sigma hat. What you all got, because that's the most important thing. One point five two, correct? 1.52. Close it together, 1.52. The sigma hat. Check and make sure you're using the same formula. That's the most important thing in the questions, that we get the same sigma hat. Right, I gave you about 3 different formulas, right? Remember, I also gave you one if they give you sample variance. Right, once you have that, for all your hard work finished. Right, it will now be what, X bar. It'll be X bar plus and minus 1.96. Right, by 1.52 all over the square root of it. And we know what X bar is. Oh wait, no, I didn't work out X bar. X bar was 5 over 50. X bar is 10.5. Right, so yeah, you have to work out X bar too, because I didn't give it out. 525 divided by 50. Check it over, tell me what you get to conclude, right? Trouble? Bring a trouble to the. Huh? That was the real. Thank you again, sure. What do you do to get sigma then? So you had to find it, right? Once it didn't give you a value, you have to estimate it. Oh yeah, finish it up, tell me what you get to conclude. Right, check your boundaries. I am seeing here 10.08, 10.92. Close to that, right? Any of those? Where have you bracket there? Oh, you're still looking over. Great, how about that? I think it's very good. Great, that's it. Very fine. Right, you got the values? All right. Or one, then and break it, or break now. No, you decide. Yeah, one more. Start late, when I'm starting now 15 minutes late. That's a little bit different, that's how we try that, and then we will stop and start up. Right, so let's try this past paper. Any questions there online? Sebastian, are you okay?
See, it includes them.
Cool, cool. Cool. Well, yeah, the good spot, come here, come on. So that whole row there, but those two rows there, but. Let's try 2019. What do you mean by width? What do you mean by width, Nathan?
Yeah, you must know it now.
Right, yeah. That's a width of about, what does that mean? Okay, so tell me how I'll find the width of the example on the board. 5.08, 5.16. What you do to get the width of the interval?
We did use it. Oh, why not?
What you do?
Choose.
Huh?
Sure.
Think about it. You have a length here is 100 meters, and here's 50 meters. What you would get the width between them?
Looks like option. Maybe that's the speed.
What you get the width? It's just minus? Yeah, so minus. So when you minus the boundaries, you'll end up with that. So the results of a certain exam have a normal distribution with a mean mu and standard deviation 50. Number 5. 2019, I said. Okay. Determine the sample size that is needed for a 98% confidence interval. For mu to have a total width of 8. You get time then. We answer that in 2 minutes, you're getting a longer break. Pick up the one from the back and hide it from them. Yeah. Old one plug it on the more. What the word? I don't know, you pick up the one from the back and hide it. I know where it was there. That was it was used for the infection. Pick it up and you hide it. Take it down. I know. Anything else? Right, so the problem here is to get that, the problem here is to get that, the problem here is to get that, what do you call it? Critical value. Right, so remember, we have 98% here. So here will be 1%, here will be 1%. So it means that the value that we're going to read off is 0.99. Right? What's the critical value for 0.1, 0.99? 2.2.32. Nice. So whenever you subtract now, so remember we need to get the width, right? In order for us to get the width, we have to subtract in the boundaries. That's okay? Well, what will happen? What will happen when you subtract x bar plus 2.326 sigma root 10, you minus x bar minus. What will happen when you minus those two things there? It will equal to 8. Nice. Simplify it and see if we can find it. Right? All they mean by class width is subtracting the upper and the lower bound, upper boundary and the lower bound. Get it good? Whole number. Close. So you have to round up. You round down. You round this. Then it might reach 98%. It's like what? Relative to the lower value. What you use 2.2.26 equals it. Plug it in and see. Plug in the lower limit value use, round down value and see what you get. Begin it. Close the above. Right, so you might recognize X bar cancelled and you'll get 2 by 2.326 by 15 over the square root of n is equal to 8. Right? The sigma those cancel over. So divide both sides by 2. Divide both sides by 2, and I got root n to be 2.326 multiplied by 15 all over 4. And then square both sides. Online, what you all got for n? Do it on my pi. What shall I get for n? 17. There. 76. Oh, 76. 76. Anybody online got that? Sebastian. All right, so that's the way you handle questions like that. It have more to it, but a little tired, right? So we'll actually not me. Do the last part one time. Last part, and then you get a break. So I got 76, right? Last part. Calculating me now. No, wrong. I'm just 76. And part okay. Same part and part 2. That's why I calculate the mean and I give it the 2 Good help? Yeah. Right. Fine. You overthink it, yeah? Remember I told you how to get out. the special property, but not special, that's not anything to do with B, it's just 2 marks, right? But it carries the bar from before. That's something else. I come back and use that now. Just 2 marks. Where you gonna do, Sabira? I told you something a little while ago about where the mean lies in the boundary. Where does the mean lie within the, does it lean? Where does the mean lie? Where does X bar lie? In between the boundaries, right? But exactly where? In the middle, right? It's in the middle. If you check the formula, right? If you check the formula is plus and minus critical value by sigma and root n. So X bar, your upper boundary is plus critical value sigma and root n, and your lower boundary is minus sigma and root n. So it means that when you have your lower boundary of 31.77 and an upper boundary of 33.23, it means that your X bar is right in the middle of two of them. Right? Your X bar right in the middle of two of them. Same width on either side, right? So add it up and divide by 2, and you got what? 32.5. What's the next method to work it out? The next method, you might have to go and solve for n and then plug it back in the formula. A long way, a long way. But you don't have to do it in this case. All right? All right, take a little break. You have 10, I'll get 15 minutes. And then we go and we'll go and do the T distribution. Right, take a little break online, eat something, and then we going back and do some more with the T distribution. Right, we start back in 15 minutes, right? 7:10.
Yeah. Go so I think talk anything. But I'm nothing. It's fine, talk anything.
There are two more to do, right? All right, open up the table now. Let's take a look at how to read the T distribution. Walk outside. And come back, okay. Right, pull up your T distribution. Right, so look at the normal distribution. You know the shape, right? That's the shape of the normal. Look at the shape of the T. What you recognize about the T? Quite similar, right? Quite similar, right? It just have a higher peak. The normal a little bit flatter because of the amount of values it have. But the T distribution a little bit very similar, but a little bit higher because it have less values in it. All right. So how do we read off the T distribution? Very similar to the normal. The T distribution, they read off everything less than. Right? The shaded region there is less than. But the difference with the T distribution is that you're going to have something, you're going to have something called the degrees of freedom. So if you look at the V, that's the outermost left hand column. You will see V is 1, V is 2, V is 3, V is 4. And based on the probability you're reading of 4, so let's just say you're reading of 0.9, you look for where 0.9 coincides with V is 4. And that'll be a T value, 1.533. That's okay? So you're looking for where they both coincide. So you're looking for your degrees of freedom, which might be 4. And let's say your probability is 0.9. You're looking for where they intersect. And they intersect right here. 1.533. All right? Give me a minute. Let's take a look at how to read some values. Nice. Let's take a look at how to read some values. So as I said, you have to get a probability or significance value, and n you need to get degrees of freedom. Sorry, 3. Right? You need to get your degrees of freedom. So let's use a table and I'm going to read off one from us. Use alpha as 0.95. Use alpha as 0.95 and use our 10 degrees of freedom. Tell me what you get. Go to your table, tell me what you get. How much you get? Sorry, I said 10 degrees of freedom. So 1.812. Nice. Okay, nice. So we are going now to take a look at if I ask you to get a t value for your confidence interval. To get a t value, it will be t alpha. The degrees of freedom is your number in your sample minus 1. Okay? So let's say we wanted to create a confidence interval. Let's say the confidence interval 95% confidence interval. Push up 7. A 95% confidence interval where n is, let's say, 8. What's the value that we're going to read off? Number 1, we need degrees of freedom. So your degrees of freedom, n minus 1. That'll be 8 minus 1, which is 7. Right? Remember, we want to get a 95% confidence interval, right? So, just like when you did your normal, this area here has to be what? 0.95. That's okay? So it makes here 0.25. Sorry. 0.025, and it makes here 0.025. So it means that the value that we really have to read off for is 0.975. Just like what you did when it was normal. That's okay? So the values that we actually reading off for are 0.975. So in this example, we go into 0.975, 7 degrees of freedom. So we check in to see where they intersect. And they intersect at 2.365. Are you okay with that? Yeah. So if it's a t distribution, we have the same problem where it's not reading off 95%, reading off 1 minus half of that. right? Well, not half of that, you know what I mean, right? What else? That's about it, because the sample size are always going to be small, right? And they'll give you a confidence interval, and then from that you can find a t-value, right? So what I showed you there is how to get a critical value. Okay, so write a small example down now. Find the critical value. Find the critical value for a t distribution. Yeah, same example. Find the critical value for a t distribution where n is equal to 8, where n is equal to 8, for a confidence in for a 95% confidence interval. For a 95% confidence interval. Right? And just write down that quick little things in around there. Remember your degrees of freedom is n minus 1, right? Don't Dester, grade 1, Dante Olodesel,
To check out here,
and who?
Isha.
Kesha Vedesel. One thing is a man will be there. You ready? Let's try one, right? Any questions online? Let's try one here that firstly read the scenario and tell me what you think we're gonna do. Right? Try that then.
Yes, we know.
Try that then. What do you think about this? Like pick on you. No, Joseph, pick on Joseph. Which scenario this falls under? Read it as a read on the line and see which one you think will which scenario it falls under. Remember, I gave you what? 4 scenarios, right? See which scenario this falls under. Yeah, what do you think?
This is last one.
It's the last one, right? Let's see if we can analyze why, right? It's a normal distribution. It's normal. They gave you 10 biscuits, so n is 10, n small, less than 30. And they didn't give you any sigma, right? So you have to estimate sigma. So all of that points to this is going to be a t distribution. All right, nice. So we get to there, we can just do past papers. The last thing that we have to do. Oh wait, no, I didn't show you which question as it. No, so we'll do question and then I might show you hypothesis test. Anyway, I kind of fresh. I can't do all of hypothesis testing on Tuesday, whenever in next class. But I have to do all of regression. Anyway, we'll talk about it. Just have to nasty, right? Pure two?
No, it's not good.
What y'all do in pure? Right, done. What y'all do? Y'all get how you equation to solve or you have to take up one?
Let me.
Go on. Man, is it? But then make up all your own scenario.
We use your mouth.
You're the max, remember, you're the different equation that you have to solve.
Well,
Model it and then solve it. Want to do it by yourself or play with somebody? Good. So, fine. You know? And it's here, you know what she had to do. You want to work with her? She did it with me or she did it with school? But you're just to school, right? I can't remember. Like I didn't, yeah, carry us. Yeah? Why she didn't, why she didn't? Or she did not. Too late now. So it's not too late, oh yeah, not too late now. Next year. No, but then you can't. You can't submit the same thing then. You can't submit. If we submit the same as we in school, and she submitted here. But if the same exam, let's see, then it would have been okay. They might have to just make some change to it. Right, most important thing here is not really calculating T value. The most important thing is that we get the X bar values, right? And the sigma. What y'all got for X bar? I have 397. I have 397.87. Yeah? Right, now for the moment of truth. But what y'all got is sigma. .85, that I have 3.213. What y'all got? What I get? 3 point what? For your sigma value, sigma. I use the same formula from before, yeah? 1 on n minus 1 by sigma x squared minus sigma x squared on n. Same formula from before. Anybody else got 3.213? What you got here? 1.2. And n is 10, right? Check it back and see. I see they have 10.325 for the squared value. Huh? 3.213? Right, and then you square root it. So you recognize where the problems are, right? Let's pass on to see how you do it, right? If you're not getting 3.213,000, right? Again. Same thing? Same thing, the same form. But I go down. You. I have that. Sigma x squared. So forming. That's you're using 3.96. Alright. I did it back and I got that same value. Right, but that's sigma squared, right? Or that sigma squared was 1.484. So sigma will be the square root of that, which is how much? 1.22. Yeah. Right, so let's use that 1.22. Right, maybe there's an error in this here, and they use the exact value. Right, anybody got 1.2 for their value? Yeah, alright. So we'll go with the 1.2, right? And then go right ahead and work it out. So it will be your 3 point. It will be your 3.397.87 plus and minus. The value we have is 1.22, you said? 1.22? 1.22 over the square root 10. Terminology critical value now is a T distribution with how many degrees of freedom? 9 degrees of freedom, and it's a 95% confidence interval we're trying to get. So go to table, tell me what you get. Right, and it's supposed to have 9 degrees of freedom, and the reading off was 0.975. I got 2.2. 2.262. Try not to round up too much, right? And when you use that, your boundaries are 395.6 and 400.3. Right? Those are your two boundaries. Anybody still not getting the 1.22? Oh wait, no, sorry, this is wrong. This is using their value, sorry. What's the correct answer? What's the correct answer in 1.22? 398.75. $397.0. Right, so those are your two boundaries, right? Again, you had to focus on getting that value right, that sigma value. That's generally where mistakes is be, because most times we can read the table, but we end up with different sigma values. Yeah. The degrees of freedom will be 9, 10 minus 1, and then it's 95% confidence interval. So the value you're reading up is 0.975. Okay? You okay with that? Right. One thing that I didn't get to do an example on, what would happen if they give you sample variance? Which version of the formula are you going to use? Suppose they gave you S squared. That's called sample variance. What's the version of the formula you're going to use? Anybody? What's the version of the formula you're going to use if you have sample variance, S squared? If you go and say it. Remember it. We're going to use n over n minus 1 by S squared. Right? So if you have sample variance, there's no need to go back and do anything else. Just take your sample variance, S squared, and multiply by n over n plus 1. How it is know the sample variance? They will say the variance from the sample obtained. All right? So look out for that word, right? Sample variance. So sometimes you can estimate sigma by using a sample variance. All right. Want to do a paper, but I won't tell you. Next day we will just practice a few of this, and I might do impression. And I'll leave the hardest. The hardest thing in this whole unit is really hypothesis testing. So I can introduce it Tuesday if all you want, and we can do chi-squared, or we can wait till next week. I'll decide on Tuesday, right? Can we do one Tuesday? I can do chi-squared.
So, we have class after.
No, I double today, so we don't have to start. Right? Three all those so bad. Pass well pass. How do you apply then the film? Tell me if they that. Why was hard? Question was hard. Kaya wasal. Kaya wasal na kip.
No, okay. I,